Now we proceed with the third activity, which relates to the third conjecture. Now, given the function fx equals to 1 over 2x and gx equals to 2x are the inverse function of each other. So now we know beforehand that f and g are inverse of each other. Sketch the function graph of this, of fx, for the domain. X is greater than or equals to 0 and less than or equals to 8. Before we sketch, we try to build a table where x is the domain from 0 to 8. And now we try to find the fx by substituting the value into the function. So when x is 0, f0 equals to 1 over 2 times 0, which is 0. When x is 1, f1 equals to 1 over 2 times 1, which is 1 over 2. When x is 2, 1 over 2 times 2, you get 1. When x is 3, you get 1 over 2, or 1.5. Then you get 2, 1 over 2, 3, 1 over 2, and 4. Then we sketch the function graph. We sketch the graph here. Okay, we try to sketch it now. Okay, 0, 0 is here. 1 over 2, so 1 over 2 is here. 2, 1. 3, 1 over 2. So this is the x-axis represents the object, the x, where the y-axis here represents the fx. So this graph here is representing the function of f. Now we proceed with the second activity. Then sketch the function graph of gx equals to 2x for the domain 0 to x. For the domain x is greater than or equals to 0 and less than or equals to 4. So x, the range of x is from 0 to 4. So g of 0 equals to 2 times 0, which is 0. G of 1 equals to 2 times 1, you get 2. 2 times 2, you get 4. 3 times 2, you get 6. 4 times 2, you get 8. So function of g, I'm going to use a red color pen for this. And we start with 0, 0. So it's 0, 0. You have 1, 2. 1, 2. And then we have 2, 4. So this line here represents the function of g. Now from the graph of f, what is the domain? Okay, so we go back to the graph of f. Domain, we always read domain from the x-axis. Hence, the x value is from 0 to 8, which is actually given here. The domain is here. So we just write this down, 0, 8. And the range, we read the range from the y-axis. So first we find the highest point here, which is the highest point here, which is 4. And the lowest point is 0. Hence the range is fx is greater than or equals to 0 and less than or equals to 4, because the range is this part. Hence this. Now for the graph of function of g, the domain. Again, the domain is given. The domain is x is greater than or equals to 0 and less than or equals to 4. So I just copy this. Then from the given graph, we try to find the range. Again, the range we read from the y-axis. Domain from x-axis, range from y-axis. So the highest point is here, which is 8. And the lowest point again is 0. So the range here is fx is greater than or equals to 0 and less than or equals to 8. So what can you say about the results of the findings? You will find that the value of the range of graph f, which is from 0 to 4, is the same as the value of the domain for graph of function g. So this one is equals to this. Whereas the range of the function g, which has this value, is equals to the domain of function f. This and this. Yeah, they are equal. Remember, the function f and g are inverse of each other. So how can we relate this to the domain and range of a function g and f? That is the third conjecture. If two functions f and g are the inverse of each other, then we know that domain of f will equals to the range of g, and the domain of g equals to the range of f from this activity. Now there's a second question here. How are the graphs of f and g located with respect to the line y equals to x? So this line, we try to draw this line here. So I'm going to use the blue line to represent this y equals to x, which is this. This is line y equals to x. So from the shape of the graph, we found that actually the graph are reflection of each other on the axis of reflection, which is y equals to x. So if two functions are inverse of each other, they will reflect each other on the axis of reflection y equals to x. This brings us to the next part of the third conjecture. The graph of g is the reflection of the graph of f at the line y equals to x, provided that g and f are inverse of each other. Then g is the reflection at the line y equals to x. Now for the last conjecture, the fourth conjecture, we are using this graph again. So we take a look at this point here. The coordinate of this point is 8, 4. And the reflection of this point, which is this point here, has a coordinate of 4, 8. 4, 8. So now we try to take any other points here, like for example this point. What is the coordinate of this point? 4, 2. 4, 2. And if this point is reflected at the axis of reflection, y equals to x, this will be reflected to this point. And what is the coordinate of this point? It's 2, 4. This coordinate has 2, 4. So from these values, what conclusion can you make? You look at the x value and the y value here, the y value of f and the x value of g. The x value of f, the y value of g, the y value of f, and the x value of g. From here, we go to the final conjecture, which states that for any real number a and b, if the point AB lies on the graph f, then the point BA lies on the graph G. Notice that the x coordinate and the y coordinate, they switched position, they flipped for the inverse function. So the point BA of graph G is a point of reflection of AB which lies on the graph f. So any points from this conjecture, any point here, when it reflects onto the inverse function, the coordinates of x and y, they will switch the position. So how are we going to use this conjecture to help us? We look at example number 3. This diagram shows the graph y equals to fx. So this graph represents y equals to fx. This graph has point Q and point P. Now, State the domain and range for function f. Domain we always read from the x-axis. So the domain equals to this value here, which is 3 and 1. So x is greater than or equals to 1, less than or equals to 3. Whereas the range we read from the y-axis. On the same planes, so in order to sketch the inverse of f, the first thing we do is we sketch the axis of reflection. So the axis of reflection is roughly this, which is like 45 degrees here. We label it y equals to x. And then the f inverse will be a reflection of this line onto this line, which is this. And then you need to show the points corresponding to point P and point Q. So point P here will be reflected to this point. Point Q will be reflected to this point. And these 2 points, they intersect each other on the axis of reflection. From the last conjecture, we know that if this is the inverse of this, hence the coordinate of this will be, since this is 1, 0, this one will be 0, 1. If this is 3, 6, this one, the coordinate of this will be 6, 3. That is how we use the last conjecture, the fourth conjecture. By that we are done with question B. We go to the last one. State the domain and range for function of f inverse. And we can use the conjecture number 3 to help us to solve this, as we know that the domain of f inverse is the range of f. So the range of f is this, hence it's equals to 0. And then just be careful because it's domain, so the fx here have to change to x. And the range of f inverse equals to domain of f, which is this. And since we are looking for the range, so x here has to change to f inverse x, f inverse 3.